Okay, here we are with the final installment. This is the one that puts everything together that I set up in the three other videos. And a unit circle has a great deal of information in it. Now, I was going to fill this out for you, but I thought I'd just do it again real quick, just so that we can remember how it was built. You know that this is pi over 4. It's just 45 degrees. You got 2 pi over 4, reduced to pi over 2, 3 pi over 4. That's 135 degrees. 4 pi over 4, 5 pi over 4. 6 pi over 4, this is 225 degrees. 6 pi over 4, that's that, reduced 7 pi over 4 here. And this is going to be 315 degrees, right? This is 2 pi. That would be 8 pi over 4. Anyway, so we'll start with this. If we were just dealing with this right here, because if I put the 30-degree ones on there, it's going to get too busy, but we'll do a new circle on the next page for that. So I just needed to show you this. First of all, this is called the first quadrant. You know that. This is quadrant 1. This is called quadrant 2, and this is called quadrant 3 in respect of the axes here, where we basically have an x-axis here and a y-axis here, and this is quadrant 4. We know that coordinates in this quadrant are positive on both sides. So anything that would positive, so positive something, your coordinate would be in this quarter of the circle. If the x was negative and the y was positive, we would have a coordinate in this part of the circle. Both of the values in the coordinate would be negative here. Can you see that all the way down there? Yep. And then over here you'd have a positive for the x because you're turning to the right, and then down would be negative. So coordinates in this section would be positive for x, comma, negative. You can see that? Yeah. Okay. That's awesome. So that's important as we go on here with some of this. So the next thing I want to do is kind of think about how a triangle would fit in here. So if I were to draw a triangle, whenever you're drawing a triangle, these are called reference angles, reference triangles. And I wanted to figure out the coordinate that would fit right here. First of all, I know that this coordinate would be positive and positive because it's positive to the right, positive up. So the value of this coordinate is a positive number and a positive number in a coordinate. Look at that, that's cool. So how do you get the values in that coordinate? Well, you draw a triangle called a reference triangle. And when you draw a reference triangle, you're always going to have a right triangle. And that right triangle is either going to be 45, 45, 90, or it's going to be 30, 60, 90. One of those. In what I set up here, these are all going to be 45, 45, 90, but here's the reference triangle. This is the hypotenuse of the reference triangle. It's the length of the radius of this circle, isn't it? There's the center of the circle, there's where I am on the circle. This length is 1. It's a unit circle. If that's 1, then this is root 2 over 2, and this is root 2 over 2. If you didn't watch the other videos, this was in the third video. Now that we have that, this is simple, right? Figuring out this coordinate, because in order to get to this coordinate, I need to move root 2 over 2 from the origin to the right. Root 2 over 2 is my x. And I need to go root 2 over 2 up to get to this coordinate right here. This is root 2 over 2 up. So the coordinate at pi over 4 is root 2 over 2 comma root 2 over 2. Simple. The next one that we'll look at is this 45-degree angle. Now this 45-degree angle is actually right here. This is 45. This is actually a 135-degree angle, isn't it? This is a 135-degree angle. See to right there? 90 plus 45. 135 degrees. You could see it right here. 135-degree angle. But when I draw my reference triangle, the angle that I'm looking at is this one, because I have to drop this line to the x-axis, and I end up with this triangle, which is congruent even to this triangle and similar as well, but this triangle, which is 45, 45, 90, and this is the hypotenuse or the radius, which is 1. Now in this situation, we have to go to the left to figure out this length. It's still root 2 over 2, but wouldn't it be negative because it's to the left? Going up, root 2 over 2 is also the length of that side because it's a 45, 45, 90 triangle. So this coordinate right here is negative root 2 over 2, comma, root 2 over 2. Now, I can go and draw another triangle for each of these, or we could just recognize what's happening here. We're having symmetry over the over the y-axis to get to this coordinate. Root 2 over 2, root 2 over 2 becomes negative root 2 over 2, root 2 over 2. Also making note that every coordinate in this section is negative first and positive second. Every coordinate in the third quadrant is negative and negative, making this coordinate right here, what? Negative root 2 over 2, comma, negative root 2 over 2. It's a reflection now over the x-axis from this coordinate. The x value stays the same, but the y value goes negative. Same thing over here. If we were to draw this reference triangle again, remember reference triangles are always drawn so that the, obviously I didn't do it perfectly, so that the hypotenuse is the radius of the circle. So if that's the case anyway, and we understand this, then this coordinate is going to be root 2 over 2, comma, negative root 2 over 2. Those are the coordinate positions at each of the reference angles. This reference angle, this is a 45-degree angle. Even though this is a 45-degree angle, this is the coordinate that you get as you go around the circle 135 degrees. You get to this position. If you go around the circle 225 degrees, you get to this position. Negative root 2 over 2, negative root 2 over 2. And if you go around the circle 315 degrees, we end up with this position. Again, the 45-degree reference angle, but this position of the coordinate. There's a lot going on right there. Quite a bit. Okay, so I need to keep going with this. This is going to be a longer video, but take a picture of that, whatever you need to do. Anyways, there it is. I need to get rid of it, of the insides here. Actually, I'll keep the quadrants, but we need to get rid of all this stuff. We need to go on to the 30, 60, 90 side of this. Okay, so at 30 degrees, right here, we draw this right triangle. That's the reference triangle. It's a 30-degree angle is our reference angle. This is 30 degrees right here. It's pi over 6, 1 pi over 6 in radians. Okay. We said 30 degrees, 30, 60, 90 has, this side is 1, again, still we're in a unit circle, so that's a 1. Across from the 30 is a half. Check your previous video again. This is root 3 over 2. That's the side lengths of a 30, 60, 90 triangle drawn inside of this circle. We end up with a coordinate here, right here, of root 3 over 2 to the right and 1/2 up. That's the coordinate right here on the circle. It's a very important thing to know about. If we do the next one, which would be 60 degrees, right here, the reference triangle for this has a 60-degree angle over here with the 30 over here. This is the hypotenuse, so that's 1. Across from the 30 is a half. This is root 3 over 2. So the coordinate on the circle here, x is 1/2, y is root 3 over 2. Look at these, they're transposed of each other because they're both stemming from a 30, 60, 90 triangle situation. Okay, so there's a lot going on here, but if we went to the next one, 30, 60, 90, we'll talk about the 90-degree angle separately, but the next one would be 120 degrees, right? That's 120. If you drew your reference triangle, this would end up to be 60 right there. So across from the 60, you've got the root 3 over 2. Across from the 30, you've got the 1/2. And then this is 1. This coordinate would be what? Well, 1/2 is this length, but it's negative. Remember, every coordinate in this section is negative first and then positive. Root 3 over 2. We can also look at this as a reflection over the y-axis from this coordinate. See this 1/2? Now it's negative 1/2. See this root 3 over 2 stays the same because we didn't change height. The height is still straight across here. We could do the same thing over here. The height will still be the same. The y value isn't going to change, but the x value is going to go negative. That's going to be the coordinate at 150 degrees. With a 30-degree reference angle. And the 60s here, across from the 30, 1/2, right here. Across from the 60, root 3 over 2. But we're negative because we're to the left of the y-axis. That's the coordinate there. Now remember, we just did the 45s. Those are in here as well. Those are root 2 over 2s and stuff, and negative root 2 over 2s. Okay, so think about this one. That's 210. Think about this one. That's 240. Think about this one. That's 330. And this one, whoops, that's not 330. This is 330. This is 300. All of the radian measures of those as well. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. 8 pi over 6, which is 4 pi over 3, 9 pi over 6, 10 pi over 6, which is 5 pi over 3, 11 pi over 6, 12 pi over 6, back to 2 pi, but that's from a different video, but still, it all goes together here, right? This coordinate, what would it be? Now, just use the idea of a reflection. That coordinate is reflected of this one. It's vertically lined up with it, so that means that the horizontal hasn't changed. We're not changing the x. It's still negative root 3 over 2. But the vertical is flipped over the x-axis, making that negative 1/2. I understand this is getting sloppy. It's hard not to make it sloppy at this point. But notice that both of the coordinates are negative. What's this one going to be? It's going to be built from this one straight down. So the coordinate for this one is going to be negative 1/2 again for the x, but negative root 3 over 2 for the y. That's this coordinate. What about this one? You can look at this one up here and drop it down, so the positive x is still positive, but the y value is flipped to negative, right? So this is 1/2 comma negative root 3 over 2. And this one from here, the root 3 over 2 is still there, but still positive because we're still moving to the right of the y-axis. And then you got a negative 1/2 here. Okay, there's a lot going on there. A ton going on there. If you have your internet up, you just look up a unit circle and you can see all this information there. We basically just filled in everything on a unit circle. So that's pretty cool. The last thing I need to talk about, and I realize this video is pretty darn long now, are what we call the quadrantal angles. What are the deals with the coordinates on the axes? Well, those are pretty easy, right? We got our unit circle here. This coordinate right here is 1 to the right, 0 up. That's 0 degrees. This coordinate right here, 90 degrees or pi over 2, is 0 units to the right or left, 1 unit up. This one, negative 1, 0. This one, 0, -1. So those are the coordinates, obviously, of the on the axes. These are what we call quadrantal angles. Okay, there's a lot going on there, and a lot more actually that needs to be discussed. Let me stop this video for now, and I want to make probably one more video. Wasn't that fun?